Yeah.
Okay. So from this given questions, given question, we can see that ball A, they say, is thrown vertically downwards with an initial speed of 2.5 meters from point X. We can see that, and then they say above the ground at the same instant, a second identical ball B is dropped from point Y, which is located 5.2 meter below point X. And they tell us that both balls hit what? The ground at the same time. They need us to ignore the effect of air friction. First question, define the term free fall. Do you know what is free fall?
Yeah.
So when we talk about free fall, we are talking about the motion under the influence of force, gravitational force only. That's a free fall. We are talking about the motion under the influence of gravitational force only. Okay?
Okay.
Right. So now they say that calculate the time taken by the balls to hit the ground. So now they said that both balls hit the ground at the same time. So this tells me that they traveled at the same time. You understand?
Yeah.
Maybe we can just quickly do our data here. Let's see what we have. Let's see what we have. Maybe we can work on this for what? Maybe we can work on this for, what can we do? They want us to find delta T, and we're going to need the data. Ne? Let's do data. First, let's do data. I'm going to say that from the given statement, if I'm just trying to, let's start with what was given. Let's start with ball A. For ball A, what was the initial? They gave us the initial V initial net. They said V initial is what? V initial is 2.5 meters per second. 2.5 meters per second. I'm just going to write it down there. So if this is 2.5 meters per second, this was the only thing that was given. So let's say we take down as positive, okay? You understand when I say down as positive?
Yes.
Okay, we take down as positive. So if we take down as positive, this tells me that for ball A, I'm going to have the acceleration of 9.8, which is also accelerating down. It will be positive meters per second. That's what I have so far. This is the only information I have. I'm not sure if you understand when I say this is the information that I have on ball A. Let's work with ball B. Let's see what is given with ball B. Ne?
Okay.
So now on ball B, they say that ball B, I need you to understand something here. For ball B, they said difference between thrown vertically and dropped. If you drop something, what is the V initial? Come on, Kiara, I trust you're going to give me the right answer. When you drop something, what is the V initial?
0.
0, exactly. So now the V initial for B, V initial will be 0 meters per second. Okay, this is what we understand so far, because we are trying to take this step by step. Ne? So now, ball B also has the acceleration of what? 9.8 meters per second squared, because it is traveling downwards. You understand?
Yeah.
So now, what we know is that they said, okay, these two balls are identical. So now, we are missing something here. We are missing delta Y. We are missing delta Y this side. We are missing delta Y on the other side. We are missing delta T on the other side. We are missing delta T. But now remember, delta t is what we are trying to look for. Now I'm going to teach you something. You see now, from this data, you can see what we need to do. I'm not sure if you know what we have to do from this given data. We have two unknown variables and we are looking for delta t. So you know what you're going to do. Let's go to the formula sheet. Let's choose a formula that we can use. So I'm not sure. Let me move down and see my formula sheet, what we have on the formula sheet. Okay, this is the formula sheet. Okay, so from this formula sheet, can we use this formula? Nope. We don't have the final velocity. We don't know the velocity that it will hit the ground. So I've cancelled two equations so far, you understand?
Yeah.
Obviously, this one also, it has the final, it won't work. We only left with one formula. But now we are talking about the vertical one. This one is for horizontal delta x. This is the formula that we're going to use. Are you happy? We have the v initial, delta y question mark, delta t question mark. Can we use that formula? Don't worry, I'm going to teach you something now, because to understand the question is the most important part. Why we're having these sessions is for me to help you. First thing first, I did data and then I chose a formula. Even though we don't know what we're going to do yet, but let's work on this. I'm going to say we chose a formula that says, the formula that we chose, it was delta y. It's equals to what? V initial delta t plus 1 over 2 a delta t squared. Let's say we start with ball A. Let's substitute what we were given with ball A. Né? Okay, so for ball A, delta y, it's equal to, we said V initial is what? 2.5. Né? Delta t plus 1 over 2. We said the acceleration is 9.8 delta t squared. This is what we had from that data. You still remember from ball A, né?
Yeah.
Let's do the same for ball B. Let's do the same for ball B. So now, this is what I have. Maybe I can call this equation 1. Therefore, I need to move for ball B. So if I move for ball B, I use delta y. It's equal to, let's just substitute. We know that we're going to substitute in that equation. We said the initial is 0. Delta t plus 1 over 2. 1 over 2 what? 1 over 2a, the acceleration is still 9.8 delta t squared. So now I need your attention, Kiara, on this. Né? I need your attention. We have two variables. We need to eliminate one. Obviously, we can't eliminate t because this is what we are calculating. The question said, calculate the time taken by the balls to hit the ground. So we need to eliminate y. So what you need to ask yourself, how am I going to eliminate y? We can do something here. You remember now, we can find what we can do here. Let's talk about this delta y for ball B. Delta y for ball B will be the same as, so these two, to find delta y for B, we're going to take delta y, which is this one of A, the answer of A. We need to minus the height of that ball B. I'm not sure if you understand that part. Remember the difference between these 2 points, it's what? 5.2. So if, let's say this was 30, to find the height of ball B, it will be 30 minus 5.2. Then it will tell us the height of ball B. You understand that part?
Yeah.
So now what you're going to do is that you're going to say delta y minus that 5.2. It's equal to, this is just 0. We have plus, maybe 1 point, we have half into 9.8 delta t. Okay, so now let's arrange this. So this will be delta y. The 5.2 will go to the other side to be positive 9.8 delta t. So now someone can say, how are we going to eliminate one variable? So now we are positive that these two heights for ball A and for ball B, because we subtracted the 5.2, they are equal. The height of ball A now and the height of ball B are equal. So what I'm trying to say is that this and that, now they are equal because we subtracted that 5.2. We can equate these two. We can say delta y, which is the first one, is equal to delta y, which is the second one. So on the first one, we have 2.5 delta t, 2.5 delta t, 1, okay, is delta t plus half of 9.8 delta t squared. We're going to equate this to 5.2 plus 1 over 2, 9.8 delta t squared. So now I don't like wasting time, né? So I'm just gonna give you this. Remember, I have this, you see, this half of 1.98, and I also have 1 of 9.8. They are in different sides. The one is in left hand side, the other one in right hand side. So if we group them, they will cancel each other. One of them will be negative. So this tells me that I will be left with 2.5 delta t. It's equal to what? 5.2. So now I can just divide this by 2.5 by 2.5. Therefore, I'll have my time and know what is delta t equals to. What do you get on your calculator?
I got 2.08.
But don't forget, this is in seconds. I think, do you like the method that we used to answer this question?
Yes.
You understand what I did?
Yeah.
So now the most important thing is, because you're going to say, I don't have delta y, I don't have delta y, and I'm looking for t. Now you'll be trying to calculate delta y. No, don't do that. What you need to do is that once you have your data, write down there the formula down, choose the formula that you need to use. Then if you can manage to know that if you subtract the difference from the height of ball A, these two will have the same height. So this tells you that ball A is at this point. They have the same height. You can equate the two equations. You understand? And that's how you solve that question, where they say the time taken by the balls to hit the ground. Are you happy with that, ne?
Yeah.
Do you have any question based on what we did to solve this problem?
No.
That was massive, I think. This is the best solution you can use. This was massive, ne?
Yeah.
Yeah, you just have to, I think another, when you do your question, your question paper, you need to ask yourself questions, try to answer yourself. You'll say that, I have delta y, but now, can I equate these two? No, I can't equate them. Again, you're going to start from these 2 points. This is equation 2. You're going to say, can I equate delta y and delta y? No. Why? They are not on the same level. How can I make them to be on the same height? I can subtract the height of the 5.2 so that they can be on the same. You understand? So now that you subtracted, you can make that delta y subject of the formula so that you can equate the two. Are you happy with that?
Yes.
100%. I think